Thank you, Ray. Thank you. It's truly an honor and pleasure to be back to Northwestern. I had a wonderful time here at Northwestern, obviously with the research that I had with Wei Chan, and also, several afternoons I used to run along the lake. It's a great time. The title of my talk today is 3 words: green profit design. So the question that we want to pose here is that can green be sustainable? And in the beginning of the talk, I'm going to show you 3 seemingly unrelated topics to see how they could be actually linked and related together for the green profit design. Okay, so ready? So let's start with this one. First, how is the flu spreading in the US and across the world? I watched the movie Contagion. Within a few days, it's all over, right? Through the human interaction, as well as airborne, different activities. So here, there's a flu spread symptom, or the phenomenon that's coming in. That's one. Second, all of you, at least I know, have at least one account in one of these. Facebook, YouTube. You purchased some items from the Amazon.com. I did. So we have a heavily interaction with this social media. And through the social media, a lot of the user-generated contents are being generated. This was not there 10 to 20 years ago. So that's the second piece. Third piece that I like to talk about is a product life cycle. From the cell phone all the way to this heavy-duty construction equipment, we are looking at the life of a product. So these 3 pieces, seemingly not directly relate to each other, how would they be related under this theme called green profit design? That's the talk today. Okay. How did this research start? I took this picture from Professor Wei Chan's research lab website. I did my postdoc here at Northwestern, 2004, after receiving PhD from this gentleman here, Professor Panos Papalambros from Michigan. And I was very happy. And I am still very happy looking at this picture. And look at this guy. His name is Deepak Kumar. He was my buddy when I was doing my postdoc. He was a senior PhD student. He is now at Google. So he and I, we had many of the discussions, fun time, played tennis together, and did some research together as well. And after he finished his PhD, we still kept contact and exchanged some ideas and so forth. So some of the research that I'm presenting, the design research I'm presenting today, has some credit go back to Deepak Kumar. Okay? So with that, let's go back to the flu symptom. How does CDC, Center for Disease and Control and Prevention, detect the flu influenza or influenza epidemics in the US or in the world? If you have ILI, influenza-like symptoms, what do? You go to see your physician, and then physicians collect data and report to the CDC or vice versa. So all the data, ILI symptoms, are being collected through this CDC. This is a map that I got from the CDC website. The green means it's okay. But when you have the epidemics and some sort is coming in, you see the color changes. Right now, it takes how long to detect these epidemics? It takes about a week to detect this flu epidemic or influenza epidemic or anything. So now think about it. You might have bad experience with the flu or cold. If you're a healthy person, usually it takes about a week, you're over with it, right? So by the time that you have this 1-week delay, chances are you are over with it or you're already infected without the warning. How does Google do? This is a Deepak, my buddy, sent a paper that is published in the Nature. If you have a flu symptom, some of you might actually go to google.com, type in the keywords. I have a flu symptom, what is the medicine for flu, and so forth. Google collects the data with the tag of the time and probably location where the search queries were made, and then compile the data into google.org. Have this special page for the flu trend. And this is a paper that was actually published in the Journal of Nature with some of the folks working in Google. The red line represents the data that is being collected in the CDC. The black color represents what people actually did in terms of submitting the search query. And then you see that the pattern is actually matching with the CDC data quite well, with almost no delay. So Google can detect the influenza epidemic almost without no delay across the world. Okay? Deepak, this is a great paper. Can I use some of this idea for product design? Can we utilize some of this user-generated data like this? So if you look at this line, this is actually the current time frame when the paper was written. And this dotted line is actually some of the forecasts, some of the prediction. Okay? So we have this whole bunch of regression or forecasting tools that's available. Based on the past data, now you can see when it's going to peak again. Right? Very powerful tool.
You say almost no delay, but CDC had sort of the 1 week delay. So in other words, you're saying it's about 1 week for Google as well?
So what Google predicted is actually confirmed by the CDC.
So the 1 week delay of the CDC, Google does not see that 1 week delay?
Right. I know right away where the flu is happening right now. On the other hand, if you have to wait for the CDC information, you got to wait 1 more week. What's going on in the US right now? Well, Chicago area, guess what? It was a week ago data.
Is that because people are going to put in information search before they go to their doctor?
Well, some of us do that, right? So when I have the flu symptoms, I go to website, what is this? Is there medicine that I have to take? And, people write, things about or send search queries.
But is it also just because it takes the CDC time to compile the data and then publish it? Is that right?
So CDC data is actually real data. That's accurate compilation in the US. But the premise here is that what people's actually behavior tells would represent the symptom that they have in terms of submitting search queries. And turns out that Google showed that it actually follows very well with the actual influenza trend. So that's the first piece. Second piece is this. Look at all this junk. Are this waste? Look at all this e-waste. In year 2009, in the US, 141 million cell phones or mobile devices retired. Out of those, only 8% went through some sort of a recovery cycle. So what does that mean? More than 90% of these mobile devices that are retired, either they went to the landfill or we burned them in the incinerator. For me, as a designer or design engineer, this is an opportunity. I got to do a better job by designing a product in a smarter way so that if I can increase the number 8% by, say, up to 30%, that's going to be a huge impact. Remember, 140 million units as of 2009. Okay? Third piece here is that the product lives a life, right? So starting from the pre-life, we call this a pre-life, design and manufacturing. In that process, we extract some of the materials from the nature, and then it goes in the hand of the consumers. When the product reaches its end of life, you collect those products through some sort of a recovery channel, and then do some of this end-of-life treatment. So in that process, what happens here is that, especially for the usage stage for the equipment like this, it consumes gazillions of diesel fuel, right? So a lot of the negative environmental impact, use material, it has a lot of toxic chemicals being generated and so forth. All kinds of effects coming out of this. This is the actual chart that actually we generated from the real industry project case we're doing. this y-axis represents the environmental impact, negative environmental impact. The third and fourth bars represents the impact through the usage phase. So you might have guessed that the usage phase of this machine will count for the biggest environmental impact. Not just the design and manufacturing, but the usage phase for this particular type of product has a huge environmental impact. It does depend on the way you design a product. So with that, there are some activities now for those 8% of the product that go through the recovery channel. Some of us, we see that it's a reuse or the remend products coming out of this, right? Clean up and then sell it to the eBay. Some of us, we see this remand part. If the whole product is not being used, then you illicitly recover some of the component, sell in the secondary market. If none of this to work, you collect and send out to the recycler. They melt everything, try to recover some of the precious metals and or the raw materials. So these are the type of activities that we can expect at the end of life. Now, can this activity be sustainable? Why does my industry partner, why do they not do this recovery activity? Why is it not sustainable for them? Is it not making enough profit for them to do this type of as an incentive? A major obstacle that we suspected was that there exists a huge time gap actually between the pre-life and end of life. For the cell phone, by average, you use about 18 months. And for the laptop, about 4 years. Washer, about 14 years. And then for the construction equipment like this, about 20 years. You remember the 1 week delay for the flu case? Now you're talking about months and years of a delay between pre-life and end-of-life stage. So this is a very, very challenging problem. Right? So with that, this one shows that, just for example here, if I return the product, such as a laptop, through the website called gazelle.com, you type in your laptop spec and the year, and then it gives you how much you can get from the company if I return this product to this. Instead of just keeping it in my home and try to retire it, they give you money back. And depending upon the year and the model, you see that the values are decreasing. Right? And same case for a cell phone, try that. Go back home and type in your cell phone spec, and it's going to give you the price that you can get from them, depending upon the spec and the condition of the product. So they take back the product and then confirm it after checking the product and send you the money. As you see here, this is very much time horizon dependent. If you return the product too late, it's useless. If you return the product too early, you might actually lose some of the value that is embedded in there. Right? So the time aspect is very much essential in this case. So with that, another thing that I want to show here is that this is an old style Nokia flip phone. Outside may look about the same, but actually the product architecture, you can come up with distinctively different architectures for the same type of product. One could be very much integrated architecture, another could be very much modular. So you can probably guess, depending upon the way you design the product or product architecture, one is easier to recover, one is harder to recover. So there's a difference. The way you design the product will have future implications when the product reaches end of life. So with these pieces, another piece that I want to talk about here is that some of the user-generated content. So I have an account at cnet.com and amazon.com. When I actually purchase a product, consumer electronics, I go to those websites, and then I read the reviews. Okay? I myself actually publish some of the reviews of the product that I bought. If you look at this cnet.com, it's quite interesting in that the reviews are actually divided as a pros and cons. I'm going to talk about that a little bit. Not only consumers, gazillions of customers type in the reviews. Now, some of the products, they come with this, such as like telematics equipment. It's like a GM OnStar, right? You have this subscription of the OnStar. It can locate where your vehicle is, what the condition is. So some of these companies, such as John Deere, Caterpillar, and Volvo, they attach OnStar-like service in their heavy-duty construction equipment to identify how their machines are being used by their users. So the user-generated contents are being generated in the form of text reviews or in the form of different modes of data. Okay? So there's a user interaction going on. So many of them are being generated right now. So with that, when I talk about the green profit design, this is how it looks. From the start of the product design all the way to the end of life, I want to do two things. One, I want to minimize negative environmental impact, while at the same time, I want to maximize economic profit by producing new product, which is pre-life relabeled, as well as doing recovery activity, end-of-life activity at the end of the life of a product. So two things, environmental impact and the profit. There's another pillar, which is the social welfare, which is basically beyond the scope of this work. So with that, recapping the agenda here is you have user-generated data. How do you actually use some of the data mining tools and methods to capture some of those generated content? At the same time, how do you actually position your product in the green product concept according to the idea of this data-driven green product design? So you have these distinctively different pieces, seemingly unrelated, so I'm kind of getting into that, the connection between these guys together. So with that, let's start with this mining customer trend. So again, go to cnet.com and you can write the reviews and read the reviews, and a lot of people, they write reviews about many different types of products that you have here. And how does it work? If a person writes a review, and for example, this is actually a screenshot from cnet.com, you have two sections, pros and cons. I like this, I don't like that. Okay? This is actually a very significant part of this. The reason is that the fact that reviews are divided into positive and negative, I don't have to actually worry about to detect whether this is a positive review or negative review. So these are categorized into pros and cons right now. And then some of the words that you see here, for example, Apple iPhone 4S had the voice recognition. You know the name of the voice recognition service? It is called Siri, right? So that was not the word that was existing in the dictionary. So if you were to run the dictionary to detect the reviews, it's not going to work because the new features are being generated for the new products. So we have to have a smarter way to detect something like this, Siri, as a new product features that's coming out of the product reviews. So if a person writes a review such as this, included memory is stingy. And there's a tool, method available in the data mining, computer science domains called part-of-speech tagging. So you divide the sentence into verb, noun, adjective, and so forth, and you correlate those feature-related words and count those. And out of these many, many reviews that we have generated so far, very much unstructured. All of you, when you write the reviews, you write your own way. Very much unstructured data could be rearranged in the form of a structured data following pros and cons. And with this, these are some of the screenshots that I have. So for example here, if those features, top 3, would be showing with these different colors, and this is your present moment, I want to see how those features would be perceived in the near future. So there are tools available such as Holt Winter's forecasting. If some of the features, such as this red line, as emerging features, you want to make sure that your next generation of product can capture those emerging features. And if the features are kind of dying down, you may guess that probably this is now becoming obsolete. Right? So by combining this with the time horizon that we can have actually some of these forecasting tools that can embed with some of the features that are extracted from the reviews that we have. So with that, my team actually designed this website called trendminingdesign.com. This one actually works how it is. So it's actually running. It's not open to the public, but I have the screenshots of this one. So if you go to this website, this is what you see. This is basically a beta version that we have. So this product lineup, we did the automatic sweep from the cnet.com. And this is all the cell phones that's available as of now in the market in the US. And I picked, let's say, Apple iPhone 4S. And look at this, the pros and cons, positive reviews and negative reviews. for the positive reviews, I want to pick the top 5 words that describe the positive features of this product. And this is a screenshot I got. After the launch, you see those top 5 features, camera, Siri, the voice recognition, people like it. And these are top 5 features that's coming out of this one. And this dotted line shows some of the predictive scheme. For the new product like this, we don't have too much of the data. So what I did was, I went back to Apple and then plugged in all the cell phone models that I have. And top 5 features, look at this. This is your current timeline. And then this is the reviews that are being generated. And as you see here, whenever there's a new product launch, there's some peak of the reviews coming in. If this prediction follows, guess what? We're going to expect iPhone 5 pretty soon, in the first half of the year, right? So usually it actually matches quite well. In other words, we don't know whether this one is going to be exactly behaving like CDC versus Google in terms of influenza detection. But if this trend shows something, it is doing something for us. And as of now, we have total of close to 1,700 cell phones, and then total of about 56,000 reviews are automatically in the database with the text mining forms. And it is being swept weekly basis. We can do every night, like 3 o'clock in the morning, but for now, we do this as for weekly basis. This is what we got, okay? So now, with these tools and method, now let's say I know how the market would perceive for the features that I like, or features I need to embed for the next generation of product as a design engineer or this designer. And what are the features I need to avoid because people really hate these features, or I need to work on more, right? So those are, let's say, detected by some of these tools. Now afterwards, what do we do? I'm going to show you some of the old machines and new machines. This is all the 24-pound PC. You look at this nice, less than 3-pound laptop. Starting from the bulky Motorola cell phone, we have all these things coming in. So as you do see here, market trend is changing. And especially for the product like this, consumer electronics, market changes so rapidly. And if there is a way you can actually move ahead with some of this prediction scheme that's embedded in the design process, you're going to be ahead of the curve. So with that, if I were to design the next generation of product, these are the combinations or choices I have including in the product features. As you see here, I'm not going to make tens of thousands of phones. I'm going to make probably top 5 most preferred phones under my product portfolio. So out of these many combinations that we have, how do we actually extract the most preferred combinations in the product design stage? So to do that, there are some of the well-known demand modeling techniques. This is a little bit about the mathematics and the modeling aspect of it. So discrete choice analysis that is established in econometrics, very well used, as well as something like this decision tree classification in the data mining domain, very well used in the community. But the idea here is this. If I were to design next generation of a product in reflection of market trend, how can I do that? If I use a traditional method, if I am here at the time t, I'm going to do market survey in this entire classroom or entire university, and then try to match the most preferred features with the product I'm going to design. If I have a way to tackle the data that comes with a time horizon, I can actually embed some of the emerging trend, some of the standard trend, some of them becoming obsolete. So I have actually better, I would say, prediction scheme for designing the new features of products. So with that, some of the idea that has come from the present market survey only, some of them coming from the trend mining, and pay attention to these guys in the beginning. In terms of a prediction accuracy, the blue one represents the method that we developed, and the red one is available in the literature. We have better prediction scheme. Not that far, like a year from now, or like 12 time steps from now, but at least for the near future, we have actually superior predictive capability. This doesn't look like, may not look like a big difference, but if you're talking about 141 million cell phones. This is huge. So with that idea, so far, now you have a way to detect how the market is going to behave, some of the data mining tools, some of the text mining schemes, and some of these web-based reviews and so forth. So that was about product design stage, pre-life stage. Now, let's go into more about the usage stage and end-of-life stage. For this, again, look at this. I had a chance to visit this company called Recellular that is in Michigan. In a given day, they process about 20,000 cell phones. It's an amazing facility. And they clean up, put a new operating system, and sell it in the eBay. Okay? And these phones are probably sitting in your drawer in your apartment, right? So they have this collection scheme, a small envelope, you stick in there, it's a prepaid envelope, and they go directly to this Michigan site, and then they recover the cell phone, 20,000 per day. They're making good money. This is opportunity, I would say. It's not a waste for me. It's an opportunity. So with that, some of the pictures are actually taken from the site that we had. One site in Chicago, actually, a PC recovery company called PCRR. So when a product comes as a take-back, end-of-life stage, what do? You disassemble and sort them out, and then have this inventory available. And you want to build, let's say, the remnant product, a little lower spec, and then probably cheaper. And to do that, you use some of the components from this inventory. If you cannot build a new product or the new remnant product, what do? You recover some of the component only and sell it in the secondary market. If you still can't do anything with that, you send it to the material recovery. So these are different levels of recovery operations to do. Obviously, this process, reassembly and make it as a second-hand product, will probably bring in much more money. So the idea in this slide for you is that, okay, there are different ways to recover a product, but one is probably better than the other one, depending upon the amount of the profit that it can generate, as well as the operation it takes. So with that, what is the most green, if there's a word like that, most green, and profitable way to recover a product when it reaches the end of life? There are many ways to go through this one. The question is this: what to recover, how to recover, what to produce, and how to sell. So if your product design is a complicated problem, the same level of complexity is going to be probably there in the second-hand market as well. So I tried not to include any equation in this presentation, but I failed to do that, but it is just a small screenshot. So here you have an optimization model that you want to do some sort of optimal strategy for recovering some of the components of the product and so forth. And I want to show you a few of the items that we have worked on. Each of these actually represent a couple of research papers. But let's look at this. How a single product be designed would have impact. Remember the modular versus integrated? Same product outside, but the way the inside is designed will have an implication. So that's the first topic here. Second here is that out of those 20 cell phones coming in this facility, not all of them are identical. They are under the cell phone family, but they have different brand and manufacturer and so forth. So you have this product family issue. How do you make some of this product sharing decision across the product portfolio? And recovery with the market positioning, I'm going to talk about it in a little bit later, and the recovery of the multiple objectives. So in other words, all these, from the research perspective, academic perspective, actually, they're actually very, very exciting problems that you can actually write papers about. Okay? So here's one example, recovery with the positioning, meaning that how do you actually disassemble these products, whether you're going to do just simply part upgrade and then do simple reassembly. So there are many different decisions that's embedded in here that you have to identify. Here's one screenshot here. When you do make these end-of-life decisions, let's say this is your decision model that you have, one thing that you have to consider is that I have new products I'm considering. By doing this remanufacturing activity, it should not negatively affect my new product market. In other words, x-axis here is the price of your product, and then y-axis is the performance, the spec. So you have a various product in your market, and you don't want to harm these guys. Second, some of these components, they have different actual characteristics. So I'm going to talk about the next slide. And end-of-life information in terms of how much are you collecting, how many of them are available, and so forth, and coming up with some of these red dots here. While you're keeping these black dots, which is your new product, they're actually a smarter way to position your product at the same time maximizing some of the profit and minimizing environment. So with that, look at these three components. CPUs, they're very reliable, but in pretty much every year, you have new CPUs coming in, according to Moore's rule. So technological obsolescence of this product or the component is very much influenced in making this design decision. As well as, if you look at this DVD drive, technology was there. It's about 10-year-old technology. But the problem is that this specific component, the reliability is the issue. Okay? So DVD drive was like that about 5, 6, 7, 10 years ago, but oftentimes you find this as unreliable. And the chassis here, even if I buy a second-hand product, I want to at least have my box looking nice. So people actually don't like old box. Even if inside is looking old, and you want to have a new chassis here. So there are different characteristics for each of the components that is associated with this one. So with that, you see that there are different things to consider in this case. So this row represents the second-hand market product value is about 85% of the new product versus 70%. And these are the different design decisions, different recovery decisions that you do. Whether you do remanufacturing or you can recover the component only, there are different ways to tackle this along the time horizon. And then, depending upon the product residual value or the recovered value, these red dots, the positioning of the product changes. And we have a way to actually identify the optimal location of this in the market. So with that, one last piece that I want to talk about here is this. So you looked at the text mining for the pre-life and the feature side, and now you looked at heavily the end-of-life operation of the product. Can I actually link these guys together? Okay. So here, from the product design all the way to end-of-life, I'm looking at two markets. For a product, you're looking at the current market for the new products, and you are looking at the second-hand market. If I have a prediction scheme or the forecasting scheme like you saw in the case of the new product design, and if I know how to do optimally the end-of-life operation, can I combine these two together? The objective function here is that you're looking at the pre-life side profit and end-of-life side profit together in consideration of the environmental impact as well as some of the constraints that you have here. So with that, again, the same issue. Now, design problem has been changed a little bit. You are designing a product, not only you are considering the new pre-life market, I want to think about 18 months from now, how we can actually recover the most value out of it when the product reaches end of life. If I consider these two guys together, obviously there are many different combinations in terms of features, as you saw in the case of new product design. And with some of the data that we have generated here, you're looking at the present time frame for the new product, as well as the marketing trend along the time T1 to present for the predictive scheme. With these time gaps between these two guys, supposedly the idea is that you're going to consider much more information coming from the market with some of the prediction, the dotted line that you have. Some of the results that we have here is like this. For the same problem, for the case of a cell phone, this is the number that we got. 8.5%, I labeled this as a green profit. This was not there before. But looking at this, I'm going to consider the pre-life, the new design, end-of-life, recovery separately. The worst case is obviously you design new life only, no consideration of the product end-of-life. But to be fair comparison, I consider this pre-life, end-of-life separately versus according to our predictive scheme simultaneously. For the same type of condition that we have about 8.5% increase of the profit coming out of this one. This was not there before. Now that we have the predictive scheme with this linking together, this one is newly generated. 8.5% may not look that huge, but again, think about it. 140 million cell phones per year. So many products coming out in the market. And this could be quite a substantial amount of research or amount of money. So wrapping up these three pieces together, where is this research heading? So when I started to publishing some of this result, it was nice to see that some of this research outcome were shown up in the newspaper, Chicago Tribune, USA Today. And I like to graciously acknowledge some of the support from the National Science Foundation and the Caterpillar and John Deere. Actually, we are working with these guys for the new products as well as the existing product, real data that is being plugged in the product design case right now. Remember the picture that I showed in the beginning? The picture that I got from Professor Wei Chan's website? Now this is mine. Okay, so I still look pretty happy, right? And then this is my research group website. And these two guys were the two PhDs that graduated from my lab last year. Conrad Tucker, he's now an assistant professor at Penn State. And Shen Lu, he's actually, I think, happiest guy. You see that? And he's now working at Bloomberg. So you see that some of the correlation, pre-life and end of life, not only research side, there's the picture correlation going on. Wrapping up, mining some of the customer trend, smartly positioning your product in the market can actually generate some of the substantial profit down the road by considering this pre-life and end of life together. We are considering environmental impact as well. Some of the research that we're doing now are producing some numbers. So, wrapping up, being green can be sustainable by carefully linking product design and recovery together. And for that, well-designed product. I'm a designer. I'm a design engineer. Well-designed product enables more profitable, sustainable end-of-life product take-back and recovery. And for that, we would like to close the loop between the pre-life, usage, and end-of-life together to achieve this green profit design. In addition to those, these guys, CNET, Amazon, Facebook, they were not there a couple of decades ago. Now, the user-generated contents in social media bring a new opportunity for us, for designers, for design engineers. And particularly for the green profit generation, this is a new opportunity that we're looking at for the years to come. And obviously you saw some of the screenshots here from the pre-life, social media, all the way to the recovery of the system that you had. That wraps up my presentation. Thank you.